If you feel a cold coming on, or you just decide you need a massive dose of vitamin C, you probably do what almost everyone does. You reach for an orange.
Right, or maybe you pour a tall glass of orange juice.
Exactly. I mean, it is practically hardwired into our collective nutritional consciousness. We just accept it as fact.
Oh, absolutely. It's the default.
But what if the ultimate immune and metabolic powerhouse isn't in the fruit aisle at all? What if it's sitting right there in your fridge, completely underestimated, masquerading as a boring salad topping?
Right.
Or, just a rigid, crunchy vehicle for scooping hummus?
A hummus vehicle. That is usually how it's treated. It is the ultimate background character of the produce aisle. Reliable, colorful, adds a nice crunch, but rarely treated as the star of the show.
Yeah, we usually view it in terms of texture rather than function, right?
Exactly.
And that is the perfect way to put it, which is why we are dedicating today's deep dive to the bell pepper. We've been looking through a really fascinating stack of nutritional research, and the data completely exposes this everyday vegetable as, well, one of the most secretly nutrient-dense foods available.
It really is. The numbers are incredibly surprising.
They are. So our mission today is to decode its actual nutritional profile, shatter that massive, decades-old myth about vitamin C, and give you, the listener, a clear understanding of how this plant actually interacts with your biology. We want to show you how to fundamentally upgrade your nutrition without adding a single complex, expensive supplement to your routine.
I love that mission. In a landscape dominated by complicated, very extensive wellness trends, it is profoundly refreshing to find out that a food with this much biological leverage is just sitting there in plain sight.
Just waiting for us to eat it.
Right. I am very much looking forward to unpacking the actual cellular mechanics of what happens when we consume it.
Let's start with that discrepancy, because the data on vitamin C is just staggering. A single medium-sized red bell pepper contains over 150% of your daily recommended intake of vitamin C.
Which is a massive dose.
It is. That is nearly 3 times the amount found in an average orange. 3 times. Which, makes me wonder why on earth society has spent the last century crowning the orange as the absolute gold standard for this vitamin.
Well, you have to look at the intersection of agriculture and advertising for that answer.
Oh, really? It's an advertising thing.
Completely. Early in the 20th century, the citrus industry, particularly in places like California, faced massive oversupply issues. They had way too many oranges and not enough buyers.
Ah, so they had to move the product.
Exactly. So they launched aggressive, highly successful marketing campaigns to rebrand orange juice from a luxury item into an essential daily health tonic.
Wow.
And they leaned heavily into the newly discovered concept of vitamins, specifically vitamin C, which has recently been identified as the cure for scurvy.
So it wasn't that the orange was the absolute best source in nature. It was just the food with the best PR team behind it.
That is exactly it.
Yeah.
The marketing dictated our nutritional assumptions, completely overshadowing the biological reality of the food.
That is wild.
The reality is the red bell pepper dramatically outperforms the orange. And to understand why that massive dose of vitamin C is so critical, we really have to look at how the human body processes it. Vitamin C is a water-soluble antioxidant.
Right.
And that term, water-soluble, dictates everything about how we need to consume it.
Because it dissolves in water, meaning we just flush out whatever we don't use right away. We can't store it up.
Exactly. We cannot store it. And the human body is actually one of the few mammals that cannot synthesize it internally.
Wait, other animals make their own vitamin C?
They do. A dog or a cat can produce their own vitamin C right in their litter. Humans lost that genetic ability millions of years ago. We are entirely dependent on exogenous sources, meaning we have to eat it.
So it's like a daily subscription service for your body's maintenance.
That is a great way to think about it.
You can't just pay for a year in advance, eat a giant bowl of citrus on January 1st and forget about it.
No, you definitely cannot.
You have to log in and renew it every single day by ingesting it. Otherwise, the service just stops.
That daily renewal is non-negotiable. And what you are subscribing to is the primary workforce for collagen production.
Okay, collagen. We hear that word constantly in the cosmetic industry, usually splashed across really expensive skin creams.
Right, but internally, collagen is the structural scaffolding of the human body. It is a protein that forms the primary building block for your skin, yes, but also your blood vessels, your cartilage, your tendons, and your bones.
How does vitamin C actually build that scaffolding, though? Is it like a physical part of the collagen itself?
It acts more like a master builder or a catalyst. Collagen is formed in a triple helix structure picture, 3 strands twisting together to form a very strong rope.
Okay, got the rope in my head.
To get those strands to lock together securely, the body has to attach specific chemical groups, called hydroxyl groups, to the amino acids. Vitamin C is the essential cofactor that makes that chemical reaction happen.
So it's the tool that locks the rope together.
Precisely. Without the vitamin C from that red pepper, your body produces defective, weak collagen. The rope unravels. Your blood vessels become fragile.
Which is the underlying cause of scurvy. Your body essentially loses its structural integrity.
Exactly.
So eating that bell pepper is delivering a massive instantaneous workforce to secure the scaffolding of your joints and arteries. But the research also highlights that vitamin C doesn't just build things. It acts as a chemical key for other nutrients, particularly when we talk about iron absorption.
Yes, and this is where we look at the plate as a whole rather than just individual ingredients. There are 2 types of iron in our diet. Hem iron, which comes from animal products and is easily absorbed, and non-hem iron.
And the non-heme comes from plant sources, right?
Yeah.
Like spinach, lentils, beans. And from what I understand, the human body has a surprisingly difficult time actually using the non-heme iron from plants. It's pretty stubborn. You could eat a giant bowl of spinach thinking you are getting all this iron, but a significant portion of it might just pass right through you.
That happens because of the electrical charge of the iron molecule. Non-heme iron in plants usually exists in a ferric state.
Ferric state, okay.
That is a specific chemical structure that the human intestine struggles to absorb. It just can't cross the cellular barrier very well.
So how does the bell pepper fix that?
When you introduce vitamin C into the digestive process at the same time, like by throwing some sliced bell peppers into that spinach salad or a black bean chili, it fundamentally changes the chemistry in your gut.
How so?
Vitamin C is an electron donor. It literally hands over an electron to that stubborn ferric iron, reducing it into a ferrous state.
And that new state is easier to absorb.
Much easier. That slight shift in electrical charge makes the iron highly soluble, allowing it to easily slip right through the intestinal wall and into your bloodstream.
That is incredible. The pepper is literally unlocking the nutritional value of the spinach. You aren't just adding a crunch. You are running a highly efficient chemistry experiment in your salad bowl to maximize the return on investment for everything else you're eating.
You are manipulating the bioavailability of your food.
So we've established that the red bell pepper is an absolute biological champion. But this naturally brings up the question of the other colors.
Ah, yes, the green, yellow, and orange ones.
Right. I always assumed these were entirely different genetic varieties of plants, like how a Granny Smith apple is a fundamentally different species than a Fuji apple. But the data completely refutes this.
This is one of the most persistent misconceptions in the produce aisle. They're not different genetic varieties. A green bell pepper, a yellow one, an orange one, and a red one can all be the exact same fruit.
That is so crazy to me.
The difference in color is entirely dictated by the ripening stage. It is purely a matter of time spent on the vine.
I look at a green pepper now and I see an entirely different vegetable. To use an analogy, it's not a different species, it's more like a photograph developing.
Oh, like that.
The green pepper is like pulling the photo out of the chemical bath halfway through. You have an image, it's crisp, but it's a bit harsh and, unfinished. And the red pepper is the fully developed picture where all the deep colors and contrasts have had time to fully emerge.
The developing photograph is an excellent way to conceptualize it. Biologically, what you are seeing is the breakdown of chlorophyll.
The green pigment.
Exactly. When the pepper is young, it is packed with chlorophyll, which gives it that vibrant green color and that slightly bitter, sharp vegetal bite. The chlorophyll is there to help the plant photosynthesize and generate energy to grow.
But as it sits on the vine and gets hit by the sun week after week,
The chlorophyll naturally degrades, and as it fades, it unmasks the other pigments that have been slowly developing beneath it. First the yellows, then the oranges, and finally the deep reds.
But it isn't just a cosmetic color change, right? That time basking in the sun fundamentally alters the chemical composition of the plant's flesh. The nutritional profile transforms radically.
It does, and the numbers back that up beautifully.
Yeah. As they ripen from green to red, we are talking about a massive surge in nutrients. A red pepper has up to 11 times more beta-carotene than a green one. 11 times.
It's a huge jump.
Plus nearly twice as much vitamin C.
While the green pepper is still a very healthy, fibrous food, it simply hasn't finished synthesizing its nutrients. The red, orange, and yellow peppers become the true nutritional heavyweights because they were given the time to finish their chemical development.
What exactly is forming inside them during that extra time on the vine? Like, what are those heavyweights actually doing?
Two major antioxidants come online in significant quantities as the pepper matures. Capsanthin, which is responsible for that deep red pigment, and quercetin.
And what is their role?
Their primary function in the human body is to combat cellular inflammation and support cardiovascular health.
Let's break down how that actually works practically. We hear the word inflammation thrown around constantly, usually in the context of like a sore muscle or a swollen joint. But cellular inflammation sounds different.
Cellular inflammation is much more insidious. It is your body's immune system constantly firing off at a microscopic level
From what?
due to stress, poor diet, or environmental toxins. And this happens through the creation of free radicals.
Okay, and free radicals are those unstable molecules that roam around damaging cells, right?
Essentially, yes.
Mhm.
A free radical is a molecule that is missing an electron. Because it is unstable, it violently seeks out other molecules to steal an electron from.
So it just rips them away from whatever it can find?
Exactly. It will rip an electron away from a cell membrane or a protein or even your DNA. That theft damages the cell, which triggers the immune system, creating inflammation.
Wow.
This happens constantly over years. It leads to chronic cardiovascular issues as the blood vessels become damaged and inflamed.
So where do the capsanthin and quercetin from the bell pepper come into play? How do they stop that?
Antioxidants are like the wealthy philanthropists of the cellular world. They have extra electrons to spare.
I love that image.
When capsanthin and quercetin enter your bloodstream, they encounter these unstable free radicals and willingly donate an electron to them. They neutralize the threat without becoming unstable themselves.
So they just shut the process down.
They effectively put out the microscopic fires, stopping the chain reaction of cellular damage before it can trigger chronic inflammation in your heart and blood vessels.
So just by leaving the vegetable and the plant for a few extra weeks, it synthesizes compounds that actively hunt down and neutralize cellular damage.
Exactly. It's remarkable.
We've seen how these mature antioxidants protect the cardiovascular system from inflammation, but that protective filtering actually extends to our nervous system too, specifically a part of it that is constantly exposed to the outside world, our eyes.
The bell pepper proves to be incredibly versatile here.
We are all staring at screens all day, and there's a constant conversation about the dangers of blue light. The data notes that bell peppers are rich in two specific compounds, lutein and zeaxanthin.
Which, interestingly, are also found in high amounts in corn.
Right. And they're uniquely capable of protecting the eyes from oxidative damage caused by blue light.
Blue light is a very high-energy, short-wavelength light. Because of that high energy, it penetrates all the way to the back of the eye, straight to the macula.
And that causes damage.
Over time, yes. That constant bombardment of high-energy light creates those exact same free radicals we just talked about, right there in the delicate tissues of the retina.
How do lutein and zeaxanthin stop it? Do they just neutralize the free radicals after the fact, like the other antioxidants?
They do neutralize them, but they also act preventatively. Lutein and zeaxanthin actually accumulate in the macula of your eye. They form a protective physical layer.
Like a shield.
Yes. They absorb and filter out those harmful blue wavelengths before they can even strike the sensitive photoreceptor cells. They act as internal sunglasses for your retinas.
Internal sunglasses. I love the idea that eating a red pepper deposits a literal physical filter at the back of my eyeball. It's wild.
It really is.
But as fascinating as the vision protection is, the metabolic properties are what really stood out in the research for me. The data points out that red and orange peppers contain compounds called capsaicin and minor capenoids. Preliminary studies show these compounds support a healthy metabolic rate and thermogenesis.
Which is a very rare combination to find in a completely mild botanical package.
Because usually if you want a thermogenic metabolic boost from a food, you have to eat something incredibly spicy, right? You have to suffer for it with a chili pepper.
Exactly. Thermogenesis is the process of your body burning calories to produce heat. Most people associate this with capsaicin, the compound that makes jalapenos and habaneros intensely hot.
And that heat is what burns the calories.
In a way, capsaicin triggers pain receptors on your tongue, which sends a panic signal to your brain, causing you to sweat and your heart rate to increase. It burns calories, but it is an aggressive sensory overload.
So how does a sweet bell pepper trigger thermogenesis without burning my mouth? Finding capsiate in a sweet pepper is like revving a car's engine without setting off the fire alarm in the cabin. You get the horsepower without the sensory assault.
That's a perfect analogy.
Mm.
Capsaicin is chemically almost identical to capsaicin, but its molecular structure is just different enough that it does not bind to the TRPV1 pain receptors on your tongue.
So you taste zero heat.
You taste zero heat. However, once it reaches your gastrointestinal tract, it binds to receptors down there. It sends a gentle signal to your central nervous system to stimulate brown adipose tissue, which is the type of body fat that burns energy to generate heat.
So it's quietly nudging your metabolic rate upward, completely behind the scenes.
Mhm.
And what makes this so effective is the packaging it arrives in,
The
right?
physical matrix of the vegetable itself,
Yeah.
yes.
Right, because bell peppers are incredibly low in calories, but they are packed with water and dietary fiber.
And that combination is the gold standard for satiety, which is the feeling of being full and satisfied after a meal. The fiber slows down digestion, stabilizing your blood sugar so you don't get a spike and a crash, while the water content adds sheer physical volume to your stomach.
Whether you eat them raw and crunchy or you roast them in olive oil so they soften and sweeten, they just take up significant physical space.
Exactly.
So you feel completely full, you are consuming very few calories, and the capsaids are gently stimulating your metabolism to burn a bit more energy. It is extremely rare to find a food that offers high satiety through water and fiber, a mild metabolic boost, and extreme nutrient density like the vitamin C and lutein, all for such a minimal caloric cost.
It is an incredibly efficient food system. You are getting maximum biological output for minimal digestive input.
It really shifts your perspective. You go to the store looking for a bag of oranges to boost your immune system, or maybe some expensive supplement to protect your eyes or nudge your metabolism. And the whole time, a fully ripe red pepper is sitting there ready to do all of it.
Hiding in plain sight.
Let's distill this conversation down into 3 clear, actionable takeaways for you to keep in mind as you go about your week. First, respect the bell pepper. It dramatically outperforms the orange in the vitamin C game, delivering over 150% of your daily needs in just one serving, literally securing the scaffolding of your joints and arteries.
Second, understand that color is a timeline. Choosing the fully ripe red, yellow, or orange peppers instead of the green ones completely supercharges your intake. You're getting up to 11 times the beta-carotene and a massive upgrade in antioxidants like capsanthin simply because the pepper was allowed to mature on the vine and finish its chemical development.
And third, they are silent multitaskers. They effortlessly build internal sunglasses to protect your retinas from blue light, and they gently support metabolic thermogenesis while keeping you full with a dense matrix of fiber and water.
It is a remarkable resume for such a common ingredient. It really highlights the power of applied knowledge. Understanding the underlying biology of your food fundamentally changes how you interact with it.
And that is exactly why we design these deep dives for you. We want to make being well-informed as easy as a trip to the produce aisle. Navigating health and nutrition doesn't always have to involve impossible diet regimens. Sometimes it's just about knowing what a vegetable can do for you if you let it stay on the vine a little longer.
And knowing how to pair it.
Oh, absolutely. Which brings us to a final, lingering thought to explore on your own. We learned today that the vitamin C in bell peppers acts as a literal chemical key, donating an electron to unlock the stubborn non-heme iron in plant foods like spinach and beans. If you don't pair them, you lose out on a massive amount of benefit. It's a beautiful symbiotic relationship right there in the salad bowl. So this raises a fascinating question to ponder the next time you are cooking. How many other ingredients are sitting on our plates right now, completely full of locked potential, just waiting to be paired with their perfect chemical partner to actually benefit our bodies?
It's a profound thought.
Mm-hmm.
It turns every recipe from just a list of complementary flavors into a complex, beneficial biological equation.
So, the next time you are standing in your kitchen, slicing open that crisp, juicy bell pepper, you'll know that satisfying snap isn't just the sound of a mundane salad topper. It's the sound of a secret nutritional powerhouse, fully developed and ready to go to work.